this problem, so this topic also very important in database design. So we need to have good understanding on the data normalization topic. All right. The first subtopic, B.1, redundancy problem. All right, so when we store the data in our databases, first let's look at the general redundancy problem. Storing the same data multiple times. That's the redundancy. Same piece of data, but in several different tables, you may need to store that same piece of data for some reasons. So I will explain. There are some reasons, so you may need to store in that way. Although we want to avoid that, right? We want to reduce the redundancy. But this problem is a little complicated. Duplication of effort. First, let's look at the drawbacks, that part. First, obvious, duplication of effort. Same data, but you may need to maintain in several different places. So that's more effort. Need to perform a single local update multiple times. Think about when you need to modify that piece of data. When you modify it, but you have several copies, right? Yeah. So you have to keep track of all the different copies. That's not easy, okay? If you have a relatively large database, you have many tables, how do you keep track of? It's hard, yeah. So think about that. So in your database design, you need to think about that issue, okay? How to keep track of, the same piece of data, but used in several tables. All right. Yeah. Wasting storage space. Not second drawback. Yeah. Yeah. Although later we will see this wasting storage space. It's not that critical. Okay. Yeah. Because to use a little more space, sometimes we can afford it. Yeah. Yeah. The space cost is not that expensive, so we can afford it. Yeah. Yeah. But you want to see later when we look at the advantage, disadvantage. So later you will see. Yeah. Sometimes it's not necessary, but sometimes it's necessary. Okay. Yeah. If it's necessary, then we are willing to use more space. Yeah. But if it's unnecessary, so then we want to save space. Yeah. All right. Same data is stored repeatedly. Okay. Yeah. Although we want to avoid it, but if we have some important reason, we need to keep redundant data, then we need to take it. Yeah. Later, I will explain why sometimes it's important we need to keep some redundant data. Yeah. This is a big problem. Inconsistent data. This drawback is relatively big, okay? Comparing with duplication of effort, wasting storage, this one is the biggest one, okay? Biggest drawback. Why it's biggest? If your data is inconsistent, then you may have trouble, okay? Yeah. When you do your business, you have some big trouble. Yeah. This happens. Yeah. Sometimes this problem happens. Yeah. The meaning of the data, because we represent the same piece of data in different places, but when we update that piece of data, we haven't updated all the pieces. we just update some of the pieces because we couldn't keep track of all of them. Okay, so we miss some of the pieces. Then your data is not consistent, inconsistent. Then when you do a business, then you have trouble. Okay, so some places the data is correct, but some places the data old one, old value, old values, new values, they appear in different places. I noticed that problem in real world applications because database design, your way to keep track of the data, something is wrong. Yeah. So in your web applications, you didn't do a good job, right? Yeah. Yeah. So this problem, this one you have to completely avoid it. Okay, as soon as you find one data inconsistency, you have to fix it as soon as possible. Yeah, yeah. This is a big problem. Yeah, the other two not that big. The other two drawbacks. Yeah, yeah, yeah. Not as big as this one. Okay, yeah. Files that represent the same data may become inconsistent. So here, I want to explain this files. Now, why we use files here, right? This name, files. Yeah, yeah. First, its meaning. The meaning of the file. This word here means a table. When we say table, you know, its meaning. But, in the textbook, in some article, mainly the, textbook or research papers, in that kind of environment, you will see those files. The authors use those files to represent tables. The reason is, we know the table concept, right? How to store a table in a database in your computer hard drive. What's the format of a table stored in your computer hard drive? A file, okay? One table is stored as a one independent file. That format, okay? So multiple tables, so multiple files. Yeah. Yeah. So that's the underlying storage format for a table. Yeah, so people sometimes just say file, okay? Yeah. But in this environment, okay, in the database context, yeah. So if a non-database context, then could be different, okay? Yeah, but in our database context, so we know, yeah, that's the same concept. Yeah. All right. Yeah. Yeah, physically as a file on the hard disk. Yeah. So that's the reason. Okay. Yeah. So you need to connect. Yeah. So then you won't get confused. All right. Yeah. B.2, concept of data normalization. Now we want to remove the redundancy of the data as much as we can. So that's the normalization step. Okay, normalize. Yeah. So want to reduce the redundancy. Yeah. The best case you may feel 100%, right? So you remove 100% redundancy. Yeah. The best case scenario. Yeah. Right. Yeah. Yeah. But we need to look at this question globally. Okay. So not just locally. Okay? We need to consider all the possible factors. Yeah. So let's look at this topic, data normalization topic. Ideal situation. Yeah. So we do not consider, other complex factors. Yeah. So store each logical data item in exactly one place in the database. So that's ideal situation. Okay, just one place. Yeah. Yeah. All right. So in this way, we can we can avoid redundancy, data redundancy problem. But ideal, when you see this ideal word, most of time you cannot get an ideal situation. You cannot get it. Ideal, too good to be true, right? Too good to be true. Okay, yeah. So nobody can get an ideal situation. Yeah, never ideal. Okay, yeah. The life never ideal. Yeah, like that. All right. So what's the logical data item? A data item appears in multiple tables with same field, with different field names. Yeah, that happens frequently. Okay, the same concept. Okay, the same concept. Yeah. But that same concept, same item, same object, let's say, or same property of same property of an object. Yeah. So when we say data item, let's consider a field. Data item for one particular field. So that's one special property of an object. But that property could be used in multiple tables. Multiple tables use that property in different ways, right? Yeah. That could happen in different ways. Then, when people create field names in those different tables, they use different names. That could happen. Yeah. But they point to the same thing, okay? Yeah. The underlying, property of an object, same thing. Then you need to do more work to maintain data consistency. So that's why we call logical data item. Logically the same, right? Although the appearances are different. But, they point to the same logical object. Yeah. All right. The benefits of what? The benefits of data normalization. Yeah. Eliminating the data redundancy. The benefits for that. Yeah. So, several benefits. Save storage space. First, but relatively small, okay? Yeah. Save storage space. Easier update. Yeah. This is more important. Yeah. When you update, you need to do less work. Yeah. Easier. Yeah. Easier to keep track of your data. Yeah. That's more valuable, right? That's more valuable. Okay? Yeah. All right. Only change one copy. Yeah. If no redundancy, you only need to change one copy, one place. Yeah. All right. Ensure data consistency. Yeah. Because you don't need to worry about if the data is inconsistent or not. Because if no data redundancy, then no inconsistency problem. Right? So, yeah. Yeah, so that's obvious benefits. Yeah. Yeah. But the problem, you may have other problems. Okay? Yeah. At this point, you may feel we don't need a redundancy. Yeah. We want to get our data normalized. Yeah. But you will see there are some big reasons. There are some big reasons. Yeah. Yeah. actually in two different considerations. The first consideration is hard to remove all the data redundancy. Very hard. You may mess up your data, right? Yeah. You know, because the relationship too complicated. Okay. If you want to, completely remove data, so you may find some unnatural way, the way to represent the data, unnatural. So, that could happen, because sometimes you want to make your life easier, so then you have to use some data redundancy. But the second one is that even if it's not hard to, sometimes it's not too hard to remove redundancy. But second is another important factor related to performance. Okay? We want to make our data access really fast. So that's very important. Data query, data retrieval, extremely fast. In order to get fast performance, we need to sacrifice in data redundancy, in the cost of data redundancy. Okay? This is a big point. I will spend a lot of time to explain this point, the second point. So that's a very important idea. All right. So we will get there. All right. Question: should we always make our data normalized? Based on the above. So your answer is no, right? The answer, no, in general, okay? In general. You may have some special case, you make your data normalized, right? But in general, because our main concern, we want the data query very fast. That's our highest priority, right? So this is the highest priority, okay? Okay. Performance. Extremely important. All right, so that's why we are willing to pay some cost. Okay. So data storage, not an issue. We know the current cost of data storage is pretty cheap. It's pretty cheap. So we don't worry about that. Control the dependency. Then, so what's the best way to handle the dependency? Here we call it control the dependency. If you cannot control the redundancy. If you cannot control the redundancy, you will have that data inconsistency problem. You need to keep track of all the redundant copies. So that's the control redundancy. Okay? Put all the redundancy issue, problem, under your control. So then you have no problem. Okay? So then you can protect your business data well. All right. So let's look at this topic. Why sometimes data is not a bad thing. I already mentioned it in the previous slide. Performance consideration on relatively complex queries. Here, I need to expand a little bit. Relatively complex query. What's that? Our SQL queries. Our SQL queries could be very complicated. So you can imagine some query huge. People can write. Although, but we learned the concept of stored procedure. Right? Remember, so last time we learned advanced features in DBMS. The third one, stored procedure. Think about it. If your SQL query is huge, then a better way, you may like to write a stored procedure to do it. Because a huge query is hard to maintain, right? Yeah. Even if you can write it out, but other people cannot understand. When you have let's say 10 lines, so one query, you use 10 lines to write that. 10 lines actually is not that big. So there are many much bigger queries. Then the biggest problem, very hard to maintain. People cannot understand what do you want to do here. Right? Very hard to understand. So a better way is, so you would rather write a function, store the procedure, use SQL. So write a program, okay? Write a program to do, all the complex things in that function. Then it's much easier to maintain. Because in that function, you have the logic, it's easier to understand the code in that program. Then in a query, okay? A single query. All right. So here, the question is, another question. When you execute complex queries or execute some data store the procedure we use for data processing, right? Yeah. Data processing work. And sometimes the data processing work needs to take quite some time. Okay? Yeah. Quite some time to, for some difficult data processing work. Then, think about it. You may need a lot of time to get a computation result. Yeah. So then, the performance, response time, waiting time, from the user's perspective. Yeah. The users may need to wait long time, relatively long time. That's not good, right? Yeah. So you do not want your user, even waiting 10 seconds, that's too long. 10 seconds. Okay? Yeah. That's the reason redundancy is not a bad thing. Okay? So we would rather to store the data in a redundant way, but the benefit is we can reduce the waiting time for our customers, users. We can reduce. Yeah. So that's that's the, we can say, the most important reasons we use redundancy. Yeah. Yeah. I will, I will explain this point in more details later. All right. So the derived data comes from, so here we use this because the data generated is not original data. It's a derived data, right? Yeah. Because the data generated through computation, right? Through computation. Yeah. So here, the situation is, so original, we have some original, let's consider original data. Original data. In this original data, we have several tables. Okay? Let's say table 1, table 2, table n. Okay, all right. Then we do data processing. Okay, we do data processing. Okay, processing, you generate the data. So that's derived data, right? That's not original data, okay? So we call this derived data. Because if you remove the derived data, you run the same program again, you generate it another time, right? Yeah. Because if you keep the original, these tables, you just run the same stored procedure or same complex query. You can reproduce the same data again. All right. So that's why we call it derived data. So derived data comes from multiple tables, but the process to generate the derived data could take a long time. Sometimes, long time. All right, now the question. Now, in order to reduce the waiting time for our customers, we store the derived data. How about that? After we generate, we spend a lot of time. So we generate the derived data. So we don't want to throw away, okay? If we throw away, next time you need to generate it again. So let us store the derived data in a new table. Store it in a new table, okay? Yeah. Yeah. Because we know storage space is pretty cheap, right? We know storage space is pretty cheap. So let's, store the derived data. We know this set of derived data is very expensive to generate. Okay? Time-wise, very expensive to generate. So let's keep it. Yeah. All right, so when our users need to access this set of data, we just retrieve from the existing table. Then it can save a lot of time, right? Yeah. You bypass the generating process. You get the result immediately, right? Yeah. So this idea, very simple, but very effective and very important in the real world application. Yeah. Later you will see. Google search used this idea. Google search engine. That big engine, right? Provide services to the whole world. But the idea is this simple idea. Use derived data to speed up the response time of the search operations. That's the basic idea. Google search engine. See? Yeah. I will, I will use one slide to explain the Google search engine, how to prepare the data. All right. The queries to generate the data are rather time consuming. Okay, yeah, I already explained that. Even need some complex algorithm for data processing. Yeah, so whatever it is need, yeah, yeah. Because later you will see, Google search engine, when they generate the derived data, it's very time consuming. Okay. When we get there, so you will see it, very time consuming. Okay, it requires a lot of computing power. Okay, yeah. So here, yeah. So that's the point here. Okay, yeah. All right, time consuming. Yeah. All right. Yeah. Faster access if you store it in a new table with that table is, the data in that table will treat as redundant, right? Yeah. Yeah. Because if you delete it, so you don't have any loss, right? I mean, in the data, here we say, if you delete it, you don't have any loss in the sense of data, but in the sense of response time, you have a lot of loss, right? Yeah. But in the sense of data, you do not have any loss. Yeah. Okay. Yeah. So that's why the data is redundant. Here, I use a simple diagram to represent this idea. Multiple table access with complex queries. So that's the way how we generate the data. We need to use original data, but from multiple tables. Then, other than multiple tables, we still need the data generating algorithms. Some complex data generating algorithms. Yeah. To do the data processing work. Okay? Yeah. All right. Then, derive the data result, single table. That result we store in a single table, one table. Okay? Yeah. So when we need to access, we just do a single table access. Yeah. So, yeah, because actually this group of data with the with the algorithm represent some service. Okay? Like Google search, that's the service. Okay? Represent some service, request some service. Okay? In order to get that service, but you need to do the work. And this is the underlying, behind the scene. You need to do that amount of work. Okay? All right. But that work, because taking a lot of computing power, resource, so we want to minimize that work, right? Yeah, because this work, this part we want to minimize. Minimize the work. But if you store derived data, you only need to generate the data once. Then later you just use the derived data. In that way you minimize the work. You minimize the generating work. Okay? That idea. All right. So this process we call it denormalization. just the opposite of the normalization. Data normalization, we remove the redundancy, right? We reduce the redundancy. If we cannot remove, then we reduce the redundancy. But denormalizing, we add a redundancy, just opposite. Even in the original data, there is no redundancy, but your generated data, you add more redundancy to your database. So that's called a denormalization. But we need it because the benefit is huge. The benefit, we can save a lot of data processing time. That's the benefit. Okay? Yeah. All right, so you can see the benefit. Okay? Save a lot of data processing time. Right? Yeah. See? So this idea, pretty simple, you can see, yeah, but very effective in the real world applications. Actually, if you understand this idea, simple idea, well, you will see in the real world application, there are many places you can use this simple idea. And the result, extremely powerful. You cannot believe. Yeah, let me see. I may give you some example. Let me see. I want to see how much time I have, because I have my own experience I want to talk about. Data denormalization. Yeah, data denormalization. All right. Yeah. The goal, simplify the computation. Yeah. All right. But that computation, that very complex data processing, yeah, we cannot get around it. We have to go through that. Yeah. But we just do once. Okay. Yeah. This computation, yeah. So more specific, do some complex computation okay, just once. And store the processing results. Yeah. So that's the okay. All right. View. Yeah. All right. So this view. So it's a space performance trade-off. Yeah. We use more space, right? Yeah. Because we store redundant data, so we use more space. Yeah. Performance in exchange less response time. That trade-off. Okay. Yeah. So we need to pay, okay? So you have to pay it. Store redundant data. So that's the cost. We need to pay. All right. In exchange, yeah. So we need to get something, right? After we pay, yeah, that amount of money. Yeah. So what do we get? Faster response time. So that's what we get, the trade-off. Okay. All right. Use more space to exchange for better performance. That's simple. Okay. Yeah. So that's a Good decision. All right. With more effort for data consistency. Yeah, but this is also pay way. You need to pay. Yeah. You know, a lot of places you need to do more. Okay. For example, data consistency for this part, you need to do more. Okay. Think about if the original data is changed, do you need to redo it? Right? Yeah. Because if the original, some of the original tables, the data modified, you need to update. Okay? Yeah. You need to update your derived data. Otherwise, data inconsistent. Yeah. So you need to pay more effort to maintain data consistency. Yeah. Yeah. All right? Yeah. So you can see the cost is pretty high. You know? The cost is pretty high because the benefit is huge. Okay? Yeah. So you have to accept that relatively high cost, high data maintenance cost. Anyway, all right? Yeah. All right. All right. A useful idea in application. So that's the point. So I emphasize this point because you may benefit when you go to the real world to solve real world computation problem. Yeah. Sometimes you may have that chances. Yeah. If you have this idea in your mind, okay, understand very well, then you may do a great job. Okay, you may greatly improve the overall efficiency. Yeah. So here I want to spend some time on this point. I hope I can give you some big impression. Right? Hopefully, in the future, for some of you, so you may benefit from this understanding. Okay? All right, so then you say something. Useful idea in application. Yeah. Google search engine, yeah, you know, yeah. So that's a big one. All right. So we call it pre-processing approach. Yeah. Pre-processing, right? Yeah. So this idea. Data processing, but there is a pre-processing. So what's that? Pre-processing. The idea is straightforward. All right? So before your users send the requests of the service, well, because when your users send a request to your data services, you need to do processing, right? Yeah. So pre-processing is before your users send requests, you do the processing before that. That's pre-processing. Okay? So you do some preparation, on the line, behind the scene, data processing before your users send the requests. You do a lot of pre-processing. Okay? All right. To generate intermediate results. Okay? All right. Then, when the user send their requests, you do not start from scratch because you already have a lot of pre-processing work. Okay? You just do further processing on top of your pre-processing results. How about that? Okay? You don't need to start from scratch. If you start from scratch, that's too slow. But you have done a lot of pre-processing work. Okay? Yeah. A lot of pre-processing work. So you can save a lot of time. Then, on top of the pre-processing, yeah, just do a little more work. Then very fast. So that's the pre-processing approach. I can give you some example. Because if I just talk about this idea in an abstract way, you won't get good impression, right? Yeah. Just very abstract. Yeah. So I want you to understand this idea very deep. All right. That example of Google search, I want to use the next slide to explain the Google search. Just the flow, okay, the main steps, just basic idea. All right. Yeah. All right. So that in the Google search, there is a step, indexing web pages ahead of them. That's the pre-processing, okay? So what do you do in the pre-processing of Google search? Indexing web pages ahead of time. Yeah. Before the user send a request, do the search. Before that. Yeah. Yeah. So that large amount of work should be completed. Yeah. Indexing web pages. What's that? Yeah. So I will explain that. Yeah. Basically, the mapping. So web pages, we use URLs, right? So web pages use URLs, represent web pages. Yeah. But URLs should map to keywords, right? Keywords-based search. Yeah. All right. So that mapping, that's the indexing. That's the meaning of the index. Okay? Yeah. That's the pre-process. Okay. All right. Impact. The performance gain is huge. So you can see, after you enter the keywords, then you get a response immediately. Usually, you'll see fraction of second. You can get, millions of pages containing those keywords, right? Millions of pages. But how can you, if you do the real-time search, how can you make that? It's impossible to make that. Right? It's impossible, right? Yeah. So you get millions of pages. You find millions of pages that contain the keywords you type in, right? Impossible. Yeah. But the idea to make it happen, pre-process approach, indexing, ahead of time. Before you type, so the data already there, the mapping already there, right? After you type your keywords, they just do the search on one table, all right? They do the search on one table. Then they return the information just from that one table. So that's extremely fast. Okay? One table query, how fast it is. Right? Yeah. All right. So that's why you can get, fraction of seconds, yeah. Get the result. Million of pages. Yeah. All right? Yeah. All right. Yeah. So here also, we use the derived data. So you can see the pre-processing, indexing, all the data, that's the derived data. That's the redundant data. Okay? The newly generated, but the generating cost is pretty high. Yeah. Google doing indexing, how many servers do they use? Right? Yeah. Hundreds of thousands. You can imagine that level. Hundreds of thousands of servers in the world, okay? Spread everywhere in the world. That many servers they use to do the pre-processing, to do the indexing. Yeah. That amount of work, definitely you want to store it, right? Yeah. Otherwise, you can imagine the electricity bill is big. Yeah, to generate the indexing data, the electricity bill used on those servers, dozens of millions in that level. Electricity bills that big. Yeah. Okay, think about that. All right, Yeah, so this one, I want to explain the Google search engine. But before that, I like to give you another example. That's my personal experience using this pre-processing approach. Yeah, very effective. Yeah. But it's a small example. So the idea I want to convey here is this simple idea is so powerful. Yeah. So if you have a good understanding that in the real world future, real world problem solving, future you may have various data related problem solving. You need to do, if you can, pick up this idea from this class, that would be great. So I like to give you another example, my personal example. 10-something years ago, I taught a class. Actually the algorithm class. So Andy, so you know that. But that's 10-something years ago. Not recently. I gave a project. One project I gave is simulation of Google Map. You know the Google Map, right? You're familiar with Google Map. But in an algorithm class, how can we do a Google Map project? It's hard, right? Extremely hard. But we can simplify it. We do simulation. Okay? So the project is, let me describe the main idea. Project, okay. Simulation. Simulation of a Google Map application. Simplified Google Map application. Okay? All right. Google Map, you need to represent map. You need to represent map data based on zip code, right? Let's say zip code. All right. So here I simplify, make it very simple. Yeah. But although it's much simpler than that map application, but you can see a lot of similarity. The basic idea is the same. All right. How do I simulate map for each zip code? Each zip code, one region represented by zip code. Okay? Map data. So I use one triangle to represent zip code. Okay? One triangle is simple, right? Yeah, simple. One triangle. Okay? Yeah. Corresponds to one map of one zip code. Okay, one triangle. Okay, yeah. All right. To load the map of one zip code, just load that triangle. Okay, the triangle we can use 3 coordinates to represent, right? Yeah. The coordinates of 3 vertices. One triangle. Okay, all right. Then in order to find a point in a map, one point on Earth, at one point you have latitude and longitude, right? Yeah. Latitude and longitude. Yeah. So that's XY. We use XY coordinates. Okay. X coordinate, Y coordinate. Yeah. So that's the, geolocation, okay? Geolocation data. Yeah. So when you do that simulation, all right, X and Y, okay. All right. Then representing the Earth, the Earth, the whole Earth, How about we just use one large square rectangle, one large rectangle to represent the whole Earth, okay, whole Earth. Okay, yeah. 1 point xy coordinate on Earth, x. All right. So this whole Earth, I decompose that whole Earth by many little triangles. Okay, yeah, yeah. So there is an operation called triangulation. Okay, triangulation. Yeah. So here, at that time, I use MATLAB. The software I use, MATLAB. Okay. MATLAB software. In MATLAB software, I started with a rectangle. Okay, so, the width, the height. Then MATLAB has a triangulation operation. Triangulation operation. Okay. Triangulation operation, I ask MATLAB to decompose the given rectangle in 1 million triangles to represent, the local regions on Earth, right? Yeah, simulation. 1 million triangles on Earth. Okay, 1 million zip code. Okay, regions corresponding, based on zip code. Yeah. All right. Yeah, this environment setup pretty close to the real world situation, right? Yeah. Now let's do the search. So you need to store 1 million triangles. That's a lot of data, okay? Several megabytes. So I upload my data to my student. You can download the data, several megabytes. 1 million triangles. Each triangle, the coordinates, 3 coordinates, x, y coordinates, one line. But you also need to store the connection. Yeah. You have coordinates, then the edges, you need to store the edges, right? Yeah. So other than coordinates, you need to store edges. So that's the 1 million triangle. So that's a big file, several megabytes. All right, so then each one download on their computer. For the university, university has the MATLAB license, so we just use the university MATLAB license. All right. So then, given xy, yeah. So given xy coordinate, you need to find which triangle contains this point. Give random point with xy coordinate generate inside the rectangle on Earth inside. But you need to search through 1 million triangles and find which triangle contains that point. Okay? Yeah. I give them formula. How to determine, given a triangle, how to determine a point is inside that triangle. So we can calculate, some determinant. There is a formula, okay? This formula you plug in the coordinates, and the triangle 3 coordinates. So formula, you calculate. You calculate, 4 different determinants. You use the sign of the 4 different determinants. You can tell if it's inside triangle or outside triangle. Okay? Yeah. So that I give them formulas, so they can do that check. Okay, check. All right. Then the first way, brute force way. Yeah, the first way. If you do not do anything, you just make the search. You do sequential search. Yeah, because 1 million triangle. So you need to go through from the first triangle. You plug in, then you check it's in or out. It's inside, then you're done. Okay. You just output the triangle coordinates. Yeah. It's like you load the map, okay? You load the map of that local region. If it's not, you need to move to second triangle, okay? If it's not, your third triangle, okay? And so on. And so on, okay? Then, if they do not do some pre-processing work here, because I want to talk about the power of pre-process approach. If they do not, then going through 1 million, they need several minutes. Okay. Although it's pretty fast, but the waiting time is several minutes. You'll find the right triangle containing that point. But several minutes waiting time, that's quite long, right? Yeah, you can imagine. Yeah. Yeah. So then I asked them use the pre-processing approach to do preparation. Before the user enter that XY coordinates, you do preparation. Okay? You do preparation. Yeah. Whatever preparation you do, yeah, because you do not know the given coordinates, right? Yeah, but you have your map data, you have the triangle data. So you can do whatever operation you like on your map data, but you store the pre-processing results. Later, when the user, enter that coordinate, then quickly give me find that triangle. But at the end, everyone made it. Yeah. Actually, I told them the algorithm. Okay. I didn't ask them. So you created one. Yeah. You created one. I didn't ask them to create one. I give them the idea. Yeah. Here, I have a few minutes. The idea is pretty simple. Let me just use the remaining a few minutes to explain the basic idea. The pre-processing idea, do registration. Do your map region registration work. What's that? Suppose this is the rectangle, the Earth data. Okay, so this is the Earth data. Okay, Earth range. All right, then our pre-processing, we divide the Earth. We can divide the Earth. Use horizontal lines. Yeah, because the Earth is too big. If we search the whole Earth, too much work, right? So let us divide the Earth into smaller regions, much smaller regions. Yeah. We draw grid, okay? Yeah, with a certain width, we draw grid on Earth. Okay. After we draw the grid, we have many smaller, let's say, square regions. In order to make it easier. Yeah, each one is a smaller square. Then think about, can we find for each square, can we find how many triangles have intersection with the square? Given a square, can we find a certain number of triangles that have intersection with the square? That should not be a big number, right? Much smaller number, right? The triangle. Yeah, for each one, you can imagine, triangle with intersection, yeah, whatever way, all right? Yeah. So we do this. Yeah. For each square, we do registration. Yeah. We have a list of triangles that have intersection with this square. Okay? Let's go through all the squares. Can we do that? Yeah. Yeah. That's pre-processing. Yeah. You need a lot of computing power, but before the user submit a request, right? So you do it. So use the time before the user send a request. Yeah. All right. So you do a lot of work, do the calculation, okay? Yeah, pre-processing. Yeah. So each square, math. Yeah. Yeah. All right. Then, now, yeah. After that, so let's assume the processing work is done, okay? Yeah. Then, now we are ready to provide the real-time search. All right, then real-time search, given a point on Earth, X, Y coordinate, can you locate which square block contains that quickly? Yeah, by calculation, because X coordinate, yeah, the width of the square you know, right? The width of square you know. So you can quickly locate the coordinate of the square. Each coordinate has a square, right? Has a, location data, okay? All right. So you, by some simple formula, so you can see which square contains the given point quickly, right? Yeah, that's pretty fast. You just do some division, horizontally you need to go to, locate between two vertical lines, and vertically you can find between two lines, then that's square, okay? So you can quickly identify which square contains that point. After that, can you find all the triangles have intersection with the square? Because if a triangle does not have any intersection, there is no chance the given point falls in that triangle, right? Yeah, because all the triangles, in order to cover that point, you have to touch the square, right? Yeah, because the point is inside the square. The point is inside square. So the triangle, in order to contain this point, it has to touch the square, right? So from the registration, the pre-process, you did a registration. Yeah. Registration work, okay, all right. So you listed, you find all the squares, but that number of squares is not a big number, right? Yeah. 10 something, 20 something should be enough, right? Yeah. 10 something, 20 something squares. Yeah. Okay. Then to search the point in 20 something square, triangle, that's easy, that's fast, right? Yeah. So from 1 million to 20, think about that number reduction. Yeah. Then the response time extremely fast. Yeah. So then the experiment, as I know, 0 point something second. Yeah. Most of the students got the search. Given point, find the triangle, 0 point some number seconds. Yeah. So that's huge, right? Yeah. I mean, without using this method, 2 point something minutes. Okay, more than 2 minutes. More than 2 minutes. Now, fraction of a second. That's some small example, small application. But this idea is so powerful. Okay? This is just example I want to show you. In a real world situation, you may have many similar situations, similar like this. Yeah. Then you use this idea, use this example. Try to connect, compare. Yeah. So Google Map, Google Map. Here I do a simulation. Google Map, think about that. Okay. All right, I run out of time, so let me stop right here.